guys, welcome to another episode related with the conversion of the regular boats powered with gasoline or diesel engines into a hybrid or full electric boats. Okay guys, remember that our propulsion system is working with a battery bank of 48 volts. And this is why in this conversion, I am thinking in a conversion, this is not the real boat, but I am creating a prototype similar to any sailboat in between 30 and 45 feet, or catamaran, or powerboat. And the idea is that you can do that conversion by yourself. You can convert the propulsion system, the motor, into electric, and also you can convert the house into a hybrid or full electric house. The motor, the propulsion system is done. You can check the episodes related with the propulsion system. And today we are going to talk about the house. The wiring of the house is almost done. I am ready with the connection of the DC and the connection of the AC. And in the next coming episode, I am going to explain the connection of the data cables. The connection in between the inverter, the links distributor, the shunt, the display, the servo GX, and the monitor. Okay, but this is the next coming episode. Today we are going to do a short review about the wiring, the DC wiring, the battery bank, the connection in between the battery bank of the house and the solar panels, the connection in between both battery banks, and some tips and some recommendations before we start with the data cables, because the data cables probably will create a confusion in the diagram because it's a lot of wires. And in this moment the system is clean, is organized. This is the situation before we are going to connect the data cables. We are going to review quickly our system, the propulsion system. This is the propulsion system created for marine technical training with the support of Broward College. This is the hybrid and solar boat created for Mr. Lopez. And this is the unit. Okay, I use a unit, Quiet Torque, electric Quiet Torque 10.0, produces for electric yachts. And I connect with a battery bank of 48 volts, two batteries of 24 volts connected in series. And the batteries provide the power positive and negative. And this is the 48 volts coming in. And I have three phases coming out to provide power to the motor. And the motor starts because I have a relay, a thermal relay. The relay is activated for the ignition switch. Immediately the ignition switch activates the system. I have power in the display, and I am ready to activate the motor. The system is running in this moment. The system is running at 1200 RPM, 1300 RPM, 1500 RPM, 1600 RPM. The batteries are 52 volts. The consumption is 0.45. Of course, we don't have load, and we have around 30 volts AC in each AC output. That's neutral, turn off. In other words, the propulsion system is ready. Later, in other episodes, you can check the procedure to calculate the motor, to calculate the battery bank, and to do the wiring. Okay, now we are going to verify the house. Okay, because the battery bank for the propulsion system is 48 volts, and the solar panels are designed to provide power for both battery banks. I connect the house battery bank, two batteries, 48 volts, Dakota batteries, in parallel. Is approximated 48 volts, 200 amps for the house. And with that power in the house, I installed this fuse for protection, because the battery said that don't connect this one with without the isolation fuse. I connect the isolation fuse here. And now I have the positive and the negative. I install an extra smart shunt over there to provide power for the monitor and for other DOD indicator, the the dip of level of the battery bank. This is the negative, another bus bar for the negative, the bus bar for positive, the cables entering here into the links distributor. I install the switch here, and here in this position I install the fuse, in this particular case 250 amps, because I have 200 amps in the battery bank. With 250 is a good protection. Remember that this is the smart shunt. The smart shunt and the links distributor, both of them, they are controllers of the positive bus bar and the negative bus bar. Both of them control the amount of power coming in and the amount of power coming out through the positive and negative. In other words, they control in the monitor the amount of power coming in and coming out from the battery bank. This is the idea of the smart shunt, and is communicated with the rest of the system with data cables through the Servo GX. The Servo GX is the intelligent part, the smart part of the system. In this particular case, I create a link of data in between the smart shunt and the links distributor. I connect this plug with this cable provided in the box of the links shunt. Okay, and this is the power, negative and positive. Remember that we have in the bottom the negative bus bar, and we have on top the positive bus bar, and both of them could be connected with the mega fuses. The mega fuse provide protection for the positive bus bar. All right, and this is the positive and negative coming from the solar panel, and this is the positive and negative coming out to provide power to the inverter charger. This is the DC. When the inverter is working in the mode inverter, is providing power because convert DC into AC. This is the AC output, and this is the AC coming out, entering in the AC panel, entering in the main breaker of the AC panel. All right, and this is the connection in between the links distributor, and this is the connection in between the smart shunt and the links distributor. And this is the connection of the data in between the shunt and the links distributor. All right, great. Today in particular, we are going to talk about the isolated DC to DC converter. This is a converter to convert 48 volts coming from the battery bank into 12 volts, because the DC panel requires 12 volts. And with this element, the input is 48 volts and the output is 12 volts. And the 12 volts enter in the shunt, and the shunt enter into the positive bus bar. Later I'm going to explain the wiring of the DC panel. This is the input 48 volts, this is the output 12 volts, and this is the capacity, the input in between 32 and 70 volts, and the output 10-15 volts. Right, this is a perfect DC to DC converter, and we can administrate, we can know this converter because the Servo GX is connected with the system, and the Servo GX is connected with the monitor, and we are going to read what happened in the system. All right, this is the DC to DC converter. Now I am going to connect the data in between the inverter charger and the Servo GX. I am going to use a regular data cable, and I am going to use the provided terminal, the VE bus, and we are going to connect here with another VE bus. But I am going to pass the cables, the wires, properly organized through the harness, and entering here properly organized in the Servo GX. We are going to do the same with the power cables coming from the positive and negative to provide power here to the Servo GX. And also I am going to connect the data cable from the MPPT and entering here in the Servo GX. And also I am going to connect the data cable from the DC to DC converter into the Servo GX, and after that everything will be connected with the Servo GX. The Servo GX is the brain of the system, is the organizer of the system. those are the wires designed to provide power, positive and negative, coming from here and entering in the servo GX. I am going to route it, the cables, organize it. And this is the cable to provide data between the servo GX and the MPPT. The MPPT have the connection here. I'm going to pass the cables, organize it here, and then we are going to connect it here in the VE camp. After that, the small panel will be connected with the servo GX. And we are going to connect another data cable between this terminal directly here, and we are going to pass the cables, organize it. Okay, now the system is done. All the cables are properly connected. Terminal resistor, data cable for the link distributor, terminal resistor. This is the last equipment. This is the first equipment. This is the links distributor. This is the connection, the data connection here in the VE bus. The data connection goes here, goes over there, and enter here in the VE bus bar. And now we have this connection. Entering in the button of the MPPT. The MPPT. Okay, we have data for the MPPT. We have data for the inverter charger. And now we have the connection of the main display. Power here. HDM3 over there. And everything is ready. The DC to DC converter is working. 48 volts entering, 12 volts coming out, and the 12 volts enter in the DC panel, 12 volts. In this moment I have 12 volts here on the DC panel coming from the DC to DC converter, and the input of this is 48 volts. We have 52 volts, 100% charged the battery in this moment. The system is ready to be explained later, the connection of the programmation of the system. This is the DC power. The DC power is coming from the link distributor. This is power coming out, and the power coming in. The power coming in is coming from the MPPT controller, and the MPPT receives the power from the solar panel.